I am going to be going over the first 3 problems of the SAT review worksheet. So, for number 1, it says, in order to clean her aquarium, Raina must remove half the water. The rectangular aquarium measures 24 inches long, 12 inches wide, and 10 inches deep. The aquarium is currently completely full. What volume of water in cubic inches must Raina remove? So first, let's go ahead and find out how much water is actually in the aquarium. So as mentioned, it's a rectangular aquarium, and we know that aquariums are 3-dimensional. So we're going to have a rectangular prism on our hands here. To find the volume of a rectangular prism, according to our formula sheet, it is length, width, height. And they tell us that it is 24 inches long, 12 inches wide, and 10 inches deep. So we can go ahead and plug that in. So when you plug that in, you should get 2,880, and that's going to be inches cubed. Now, you stop here and you're like, oh, I have the answer, right? 12,880. Well, yeah, that answer's there, but is that answering the actual question? It tells you that she must remove half of the water. So if this is the total amount of water, we need to divide that by 2 to get half of the water, which would be 1,440. So C is our correct answer, not D. All right. So for number 2, it says, which of the rectangular solids shown above has a volume closest to the volume of a right circular cylinder with a radius of 2 and a height of 4? So what they're asking you to do is find the volume of this cylinder and compare it to the volume of these rectangular prisms. So if we go to our formula sheet, we know that the volume of a cylinder is pi radius squared height. So they tell us, first, let's go ahead and find the volume of this cylinder. So they tell us that the radius is 2 and the height is 4. So we plug that in, and you should get 50.26 is your volume. So now we need to go ahead and find the volume of each of these rectangular prisms here, these boxes. And again, we know that the volume of a rectangular prism is length, width, height. So to find the volume of A, we would do 3 times 3 times 3, which is our length, width, and our height. So when we plug that in, we should get 27. For B, when you plug that in, you get 36. So far, neither of these have really matched up with our volume of 50. So let's keep going. So for C, you do 5 times 3 times 4, which gives you 60. For D, you do 4 times 4 times 4, which gives you 64. So we kind of passed up 50 here. Let's go ahead and find E. You're going to do 4 times 4 times 3. And when you do that, you get 48. So if we look at all of these numbers, the number that is closest to 50 is going to be this 48 here. It's only 2 away from, or a little bit more than 2 away from the 50.26. So our answer here is going to be E. So for number 3, it says the interior dimensions of a rectangular fish tank are 4 foot long, 3 feet wide, and 2 feet high. The water level in the tank is 1 foot high. All of the water in this tank is poured into an empty second tank. If the interior dimensions of the second tank are 2 feet long, 2 feet wide, and 3 feet high, what is the height of the water in the second fish tank? So what you want to do here is find the volume of the water that's being transferred, and then we'll kind of go from there. So first, let's find out what's the volume of the water. Now, if we have a rectangular fish tank, that's going to be this shape here again, right? We're going to use our length, width, height. Now, if we are trying to figure out how much water is in there, when you fill up a fish tank, the base fills up first, right? However, the height varies. If you think about as you're filling a fish tank, right, the height is what's going to change, the height of the water. So if we look, the water is actually only 1 foot high. So we're going to use our base of 3 and 4 for our length and width. However, it's not filled up all the way, so we're not going to use the 2. We're going to use the 1. So when we do that, we get 12. It's going to be 12 feet cubed. So now they're taking all of that water and moving it to another fish tank. And what they're asking is, what is the height of the water? Well, again, right, when you fill up a fish tank, the height is what's going to vary. You add more water, the height's going to change. So we're going to go ahead, we're trying to find out what is the height. So let's go ahead, we're going to leave height in our formula. And they tell us that for the new fish tank, it is 3 feet long and 2 feet wide. So we'll plug that in. So now, if we're transferring all of the water from the first fish tank, that volume of water is going to stay the same. It's still going to be 12. So let's go ahead and solve for the height, h. We multiply that out and we get 6h equals 12. We divide by 6, you get height equals 2. So our height is going to be 2 feet.